Imagine you wake up, you look around, and there is nothing, no cars, no planes, no internet, just the wind. You realize two things immediately. First, you are completely immortal, you cannot die. And second, you are entirely alone. Well, almost. There is exactly one other person on this entire planet. Your soulmate, your best friend, or maybe just a stranger. They are immortal too. But they are on the exact opposite side of the world. You have no way to communicate, you don't have a map. Here is the question. If you both want to find each other, how long will it take? 1,000 years? 1 billion years? Or can we use math to fix this? The physicist's approach. If you ask a physicist this question, they will give you a very simple answer. They'll say, easy. It takes 3,000 years. This calculation assumes you act like a random walker. You walk randomly for 12 hours a day, and if you get within 1 kilometer of the other person, you spot them. It's a standard diffusion problem. But there is a massive problem with this. It assumes you are a spherical human in a vacuum. In the real world, visibility isn't always 1 kilometer in a thick forest. You could walk right past someone 5 meters away and never know. Plus, walking randomly is a terrible strategy. Why would you walk in circles in a jungle? We need a strategy. We need an algorithm. The geography strategy. If you could plan ahead, it would be easy. You'd say, meet me at the Eiffel Tower, or meet me at the North Pole. But remember, you woke up here. You don't know where you are. You don't know if the North Pole is reachable. You need a focal point that is obvious to everyone, no matter where they start. The smartest move is to find the coast. Humans naturally drift toward water, and mathematically this is brilliant. You are turning a 2D search problem, searching a whole sphere, into a 1D search problem, walking a line. If you walk the perimeter of a continent, it only takes about 5 years. Much better than 3,000, right? But wait, what if you start walking counterclockwise and they also start walking counterclockwise? You could chase each other forever. You need to break the symmetry. The ant algorithm. You could flip a coin, heads go left, tails go right, that works eventually. But Randall Munro, the author of What If, proposes a solution that is much faster. He calls it, be an ant. Ants find each other using trails. You need to do the same. Here is the ultimate algorithm for the lost immortal step 1. Walk. But as you walk, leave a trail of stone markers, piles of rocks, or carved signs pointing to where you are going. Step 2. And this is the counterintuitive part. For every day you walk, you must stop and wait for 3 days. Why stop? Because you need to solve the chasing problem. By waiting, you allow the other person to catch up to you if they are behind you. By leaving a trail, you ensure that if you are behind them, you can speed up and catch them. If you find a trail that is newer than yours, you run. You follow it as fast as you can. Conclusion. Using this method, leaving signs and resting, you don't need 3,000 years, you don't even need 100 years. Even on a planet the size of Earth, you would likely find each other in just a few decades. So if you ever find yourself the last person on Earth, don't panic. Just head to the beach, pick up some rocks, and be patient. After all, you have all the time in the world.